Hello everyone, welcome to my first electronics video vlog. The reason why I'm doing this is I have certain projects that don't actually fit into the tutorials, but I thought it would be interesting for you guys to see, or maybe you guys actually might be interested in seeing. And so I decided just to put it in a little vlog format. And this project here is somebody wanted me to build a laser for them. And I have a 70 milliwatt green laser that I bought on eBay. You will see the link in the notes below. Of course, the link will eventually age. But so, anyways, let's get started. This is our data sheet. I don't know how well you can see that, but I can read it to you. We have a 70 milliwatt, 532 nanometer. That is the wavelength of light, green LED LD module specification. So the wavelength is 532 nanometer. The output wattage is 700 milliwatts. When I put it onto a light meter, it actually shows 100 milliwatts, and that's because it's actually an infrared laser diode that's shining through a crystal that gives us the green light. The beam diameter, 5 millimeters, at a test distance of 6 meters. Temperature, beam divergence. If we were going to do holography, stuff like that, and we will in the future, those would be important numbers to us, but currently they're not, because we're not doing holography. The numbers that are important for us are the operational voltage, which is 2.8 to 3.2 volts, and the milliamp, what it draws. And the light, we have 8,000 hours. I don't know if it's actually 8,000 hours. Beam length more than 1,500 meters. And they recommend less than a 30-second duty cycle without a heatsink. Now, I've had some issues with these 70 milliwatts that I haven't had on my 200 milliwatt ones. It's a good wattage. I think I might just kick back to the 50 milliwatts for most of these. Anyways, here's our laser diode, and here is our power supply, and I picked this up at You Do Electronics. Those are recycled batteries in there, rechargeable batteries. And so each AA or AAA or C or D battery, each one provides 1.5 volts. Now normally for my lasers I use 3 volt batteries that have 900 milliamp hours. And but this is going to somebody else, and those batteries, I have them rechargeable. They're very expensive. They're A123 batteries. I'll actually show you one in this video vlog. And you got to forgive me. We're not a production company here. It's just a guy who does this on his off hours after work. And so I don't have teleprompters or any of that stuff. It's all flying from the cuff. So anyways, what I did was, when I got the laser, this is the laser, and I cut off this end right here, which allows me to plug into another connector. It actually came with the other connector that you could solder into a board. We won't get into that for this vlog, but so here's the laser, here's our power supply. This of course is our soldering iron. This is our tip tinner, which you need for soldering iron. This is great stuff. It keeps your tip in good shape. If you saw from one of the tutorials, this is what I recommended for cleaning the tip. Nice and shiny. This tip has lasted me a while. So this is our tip cleaner. This is the helping hands I mentioned. I'm an old man. I didn't use the circuit board one. And there's actually a good reason for that. This is our lead-free solder. Always use the lead-free solder. Still, there's a warning about California in here. Anyways, California is really, really strict. So one of the first things we have to do is, actually, I wasn't going to do all this, but I figured since I'm vlogging it, I'll take the extra steps. This is our multimeter here, and what I'm going to do is, I know this is 3 volts. It'll be a little more than 3 volts because it's not under load. And I've got a nice on-off switch for it. So first we'll use our multimeter. And let me see if I can bring this up closer to you. You can see what I'm doing. I don't know how clear it is. I got a new video camera coming, which will provide much more clarity in macro mode. So anyways, this is the ohms portion. This is the DC volts. So I know it's 3 volts, but so I would normally go to 20. But let me show you what happens if we go to 2 volts. Okay, so we have this guy here, and we have him in our, we have the red or positive in the volts, ohms, milliamps, and we have the black in the common. And when we test this battery, we turn on the switch. And remember I mentioned these alligator clips to you? Because these probes aren't that good for certain things. So I got alligator clips on these. I have green for red and yellow for black. So let me put the green and then the yellow. And we're seeing a 1 there on our, I don't know if you could see that on the multimeter, but it says 1. It's the same thing for ohms. If we were measuring, say, a 22K ohms and we had it on 200 ohms, we'd get a 1 there. So basically, you just slowly step it up until you reach what you want. And here we go. I've got 2.333 volts, or approximately 3 volts. It's jumping between, there we go, 2.6. Now, on our data sheet, we needed a minimum of 3 volts. This will actually run with less. I've already tested it. So we've got 2.62 volts, and I don't know why. Maybe the batteries are running low. So anyway, shut off the multimeter. Let's get back to this guy. Helping hands are great, and we'll use them in a minute. But right now, the first thing we want to do to this, actually use the helping hands right now, is we want to, when you tin the tip, when you tin something, basically you're using rosin and solder. And so you're putting a solder coat on there. So that's what we're going to do. This is actually rosin core solder, and we're going to tin the tips of each of these leads. It'll help us when we solder them together later on. So what you want to do when you're soldering is basically you want to heat up the component you're soldering. And this wire can get hot, so you may want to give yourself a little bit of length. And so put the wire in between the soldering iron and the solder. Heats up, get a nice little coat on there. Do the same thing for the positive. So I got the soldering iron on the bottom, then the wire, and then the solder. Heat that up so that the solder is actually getting melted onto the wire. Okay, that one's done. And I believe these are already, they already look like they're already got a coating. Looks like they've already got a coating of solder on there, but I'm going to put another coat anyways. Any extra solder you got on your iron, that's how easy it is to clean the tip with this thing. One of the best inventions. Okay. Let's put a little on this one. This is all live and unscripted. So anything can happen. Okay, so now we got our tips soldered, of course. And prior to this, prior to me even deciding to do the video vlog, what I did was I put some shrink wrap. You have to put the shrink wrap on before you solder these guys. This shrink wrap might be a little tight. I might not be able to get it over this one after I shrink it down. But what I did was I put one piece of shrink wrap over both wires, and then one piece of shrink wrap over the positive. So what I'm going to do is when I put the positive to positive, and I solder those two together, then I'm going to put the shrink wrap over the positive wires connections, and then I'm going to heat the shrink wrap and shrink it, and then hopefully I could fit this over both of them and then shrink that one, and we should have nice tight connections and no wires showing. So anyways, back to, and you got to be careful with these small wires with these helping hands, because sometimes they can clamp right into them. So let's not get on the teeth. So we have this one. Like I said, these helping hands can be a pain because they loosen up the butterfly nuts loosen up. Okay, so we want positive to positive first. And here's our helping hands. I usually try to line those up nicely. Actually, if I wasn't making a video, I probably wouldn't be so nice about this. Back this up just a little bit. And there we go. They are touching. Okay, so now we're going to bring our solder over. And our soldering iron. And same thing, we go from the bottom. It should heat up the solder that's already on there. And solder these guys together. Okay, let's clean that. That's not the cleanest joint. Okay, that's not a clean joint, but it'll hold. We'll do better with the black. Usually I twist them around each other. I didn't in this case because the wire was a little short. But that was our laser. We had it on. We had it on when we had the multimeter when we were testing, and I didn't shut it off. So now I've shut it off. And this time I'm going to wrap the black wire around here. It'll actually be for a better connection. I should probably redo this one. It's as easy as doing this. Okay. Maybe a little hot. Okay, let's wrap this around. Let's do it right. Yeah, that way, because the shrink wrap's a little tight, and we'll be more likely to fit it over if we do it right. Like I said, this is live. Well, it's not live while you're watching it, but it's unscripted. So you're getting the real deal of everything I run into. Okay, now let's do the black. Put a good amount, but not too much because we get that constraint there. Okay. So those two are soldered together. And of course this is going to go over positive. Like that. And then that'll go over both after we shrink wrap that. Before we start shrink wrapping anything, I'm going to test. So here's our laser. And you should always have proper eye protection when dealing with lasers, even these lower milliwatt ones. You notice I have a lot of shiny objects off of here. And even though the green lasers are actually better because your eyes react more to them, there's still some unseen light in this, the infrared portion that I mentioned earlier. So we're going to take something, just so I can show you. Okay, we'll take this black surface here. It's a magnifying glass. I have a bunch of these around. We got this black surface here. And I'm going to bring this in. And I don't know if you can see that, but it's a 70 milliwatt, but it can actually burn this. And it burns black. You'll see it on YouTube everywhere. You'll pop black balloons. But this actually goes at a good distance. Yeah, and that burned a little hole in there. Okay. So this is the 70 milliwatt, and we see that it works. Works fine. This is actually a heat gun that you're seeing here. This is great for shrink wrap, stuff like that. I guess you could use a high-powered hair dryer, but heat gun does much, much better. There's two settings, low and high. We'll just use low on this right now. Make sure it heats up very quickly. So our shrink wrap is now shrinking. Go on all sides. Shouldn't take too much. Okay, now let's see if we can get this over both, which may be a chore, considering they're not the same length. Once again, these are the things we run into. Ooh, that's That's a tight fit. And I'm not going to get it over both. There we go. I'm not even going to try to get it over this. It's not going to, like I mentioned earlier, and this is just a quick project for a friend, so there's no way it's going to get over both of these. Okay. But it's still, it'll be well protected. It's not going anywhere either. And we should be able to turn on our little laser. Let's black. Test again. So actually, we'll test it this way. I don't think you could see it earlier. There's our laser. Get nice and close. Actually burn that. Let me take a look in the camera, see if you're seeing that. Yeah, you can see that. And that's it. We got a nice little on-off switch for it. And our 3-volt power supply. Before I go, this is Helping Hands. This is the solder. This is solder wick. Remember I told you in one of the earlier videos, I use it to get unsolder components from a board. This was the part earlier. This is our multimeter. And I think that should just about do it. Hope you enjoyed the video, and hope you stay tuned for future ones.